Hello everyone, welcome to the Microsoft Security community again. My name is Kishor. I'm a product manager in the Azure Network Security Customer Experience team at Microsoft. Today, along with my colleague Shabaz Shaik, we'll be walking you through how Azure Firewall integrates with Microsoft Sentinel and why that matters for security teams. Here's the agenda for today's session. We'll start with a quick overview of Azure Firewall, covering common use cases and different SKUs. Then we'll shift to Microsoft Sentinel, looking at what it is and how security teams use it. After that, we'll focus on how Azure Firewall integrates with Sentinel, including built-in detections and automated detection and response. And finally, we'll wrap up with a live demo that Shabaz will walk us through. So with that, let's get started with Azure Firewall overview. Azure Firewall is Microsoft's cloud-native network security service built to protect workloads at scale, without the need to redesign your architecture or manage complex infrastructure. It inspects traffic at both the network layer and the application layer, so whether traffic is moving in and out of Azure or laterally between workloads, it's consistently inspected and controlled. Azure Firewall uses Microsoft's threat intelligence to automatically detect and block traffic from known malicious IPs and domains, so protection evolves as the threat landscape evolves. From an operations perspective, it's designed for the cloud, so you can deploy it in minutes. It scales automatically with demand, and it supports both north-south traffic, that's traffic coming into and out of your network, as well as east-west traffic flowing within your Azure network. Azure Firewall also handles core networking requirements like outbound source NAT and inbound destination NAT, making it suitable for real-world enterprise architectures. And for resiliency, it can be deployed across multiple availability zones, providing a 99.99% SLA. Now, one important thing to understand is that Azure Firewall is not a one-size-fits-all service. Microsoft offers it in 3 SKUs, each aligned to different security and compliance needs. The basic SKU is optimized for small and medium business or lightweight scenarios. The standard SKU is built for enterprise and government workloads that need robust, scalable network security. And the premium SKU adds advanced protection like TLS inspection, IDPS, and URL filtering capabilities that are essential in highly regulated or high security environments. Now let's look at some of the Azure Firewall use cases. The first use case is a virtual network deployment. Here you can deploy the firewall directly into a virtual network using the traditional hub and spoke method. In this instance, the Azure Firewall lives within a centralized virtual network where all networks will peer directly with the hub virtual network. This allows for all the traffic to traverse the Azure Firewall, that is traffic within the same virtual network, traffic between spokes, outbound traffic to the internet, and even traffic going to or coming from on-premises or branch offices connected via VPN or express route. This gives you a single consistent enforcement point without pushing security controls into every virtual network. The second use case is virtual WAN. Here you can also deploy Azure Firewall in an Azure Virtual WAN hub, turning the hub into a secured hub. You get the same inspection capabilities as a traditional virtual network deployment, but with virtual WAN handling the routing for you. So there's no need to manage custom route tables or force traffic flows. The platform automatically steers traffic through the firewall as part of the service. This model is especially powerful for customers operating at scale with many virtual networks or branch connections, where simplifying the routing and security operations is critical. Finally, Azure Firewall can be deployed in forced tunneling mode. So in this model, Azure Firewall still performs inspection, but internet breakout or additional security inspection is handled by a third-party firewall deployed on-premises or elsewhere. This is a common pattern in regulated or highly controlled architectures where all outbound traffic must flow through an existing stack. Let's quickly walk through the Azure Firewall SKUs and more importantly, understand how to think about choosing the right one. So we have 3 different SKUs here, basic, standard, and premium. The depth of protection differs based on the SKUs, so you can choose the right SKU based on your workload risk, compliance needs, and scale. At the entry level is Azure Firewall Basic. This gives you the fundamentals, stateful layer 3 to layer 7 filtering, NAT, and threat intelligence in alert-only mode. It's ideal for smaller environments such as dev test workloads or scenarios where you need baseline protection. Then we have Azure Firewall Standard, which builds on Basic by adding scale up to 30 Gbps and more enforcement. So you get threat intelligence in both alert and deny mode, outbound web category filtering, FQDN filtering, and support for custom DNS. This is typically the right choice when you're protecting production workloads and need strong outbound and inbound controls. Then we have Azure Firewall Premium, which takes this a step further with advanced threat protection. So Premium includes everything in standard and adds TLS inspection, IDPS, and higher scale up to 100 Gbps. This is critical when you need visibility, especially into encrypted traffic or protection against sophisticated attacks. So let's break down what that really means. So when you talk about TLS inspection, this allows Azure Firewall Premium to decrypt traffic, inspect it for threats, and then re-encrypt it before sending to its destination. IDPS gives you signature-based intrusion detection and prevention, identifying known attack patterns, malware behaviors, and exploit attempts in real time. Web categories and URL filtering means instead of managing thousands of individual FQDNs, you can allow or block entire categories. For example, you can block an entire category of social media or gambling, and you could also filter specific URLs. With that, let's move on to Azure Microsoft Sentinel. As we know, Microsoft Sentinel is a CM solution. Now, what is a CM, or Security Information and Event Management System? A CM helps security teams see what's happening across their entire environment in one place. It collects security data from vast and disparate sources and brings it together into a single view. This helps security teams quickly spot threats, investigate what's going on, and respond before damage spreads. A robust CM solution is built on several key components that work together. The first one's log management. So CM systems collect and analyze logs from across the entire organization, which includes things like servers, network devices, firewalls, other security solutions, cloud applications, third-party, everywhere. And the goal of this data collection is to uncover anomalies that indicate a potential threat. So many CM solutions also ingest threat intelligence feeds, which allows security teams to identify and block emerging cyber threats. Now, the second part is the event correlation. So CM solutions are effective because they bring together data from multiple systems across an enterprise. They analyze that data and look for patterns across different entities. For example, if there's evidence of a compromised account and also unusual network traffic, a CM might identify that these two events are related and generate an alert for security teams to further investigate. So event correlation basically helps detect activity that seems benign on its own, but when combined with other activity, it can be an indicator of compromise. So then we have incident response and monitoring. So to detect threats early and minimize damage, CM solutions monitor digital and on-premises systems continuously. Analysis is displayed in a central dashboard, and the CM solution will also send alerts to security analysts based on predefined rules. Many CM solutions also include automated response capabilities. In certain instances, the CM can take action automatically based on rules defined by the SOC. For example, if the CM solution detects possible malware, it could take steps to isolate the infected system based on predefined rules. Automation helps accelerate response and frees up security analysts to focus on more complex tasks and issues. So Microsoft Sentinel is our industry-leading CM solution. So Sentinel isn't just another tool. It's the most advanced cloud-native CM in the market, trusted by thousands of organizations to secure their environments at scale. So Sentinel comes with hundreds of built-in connectors, so customers don't have to stitch data together manually. It applies analytics, threat intelligence, and automation to turn this raw data into high-confidence detections. It performs real-time correlation across different data sources to surface threats that wouldn't be visible in isolation. Sentinel supports the full SOC workflow, that is detection, investigation, response, and hunting in a single platform. It's an open and extensible CM, allowing customers to integrate third-party tools and custom logic as needed. Sentinel is available in the Microsoft Defender portal. It's generally available, providing a unified CM and XDR experience. And in fact, after March 31st, 2027, it will no longer be available in Azure portal and will be available only in the Defender portal. Now let's quickly see how Microsoft Sentinel goes from logs to action. So we have four different parts here. First is the collecting the logs. Then we have monitor and detect, and then we have investigate, and then respond. So in the collect box, we have the data connectors. So data connectors are how Sentinel ingests data. So Sentinel has hundreds of built-in connectors for Azure services, like Azure Firewall, for example, identity, endpoints, SaaS apps, and third-party solutions. This data connected by the data connectors is what gives Sentinel centralized visibility across your environment. Then we have the monitor and detect. So here we have different options such as workbooks, watch lists, analytic rules, hunting queries, and notebooks. Let's look into what these are. Workbooks provide visual dashboards to monitor trends, rule hits, traffic patterns, and security posture. Watch list. A watch list is just a list of things that are important to your business that Sentinel wouldn't otherwise know are special. So think of it as a business context you manually give to Sentinel, because by default, all logs look same to Sentinel. So let's say you have some high value assets such as domain controllers, payment systems, production databases. Now Sentinel can raise high severity alerts when these specific assets are involved. It can correlate the firewall logs, identity logs, and endpoint logs only for these assets. It can also trigger different automations for them. So that's how you can use the watch list. Then you have threat intelligence. So this enriches raw logs with known malicious IPs, domains, and indicators. Then we have analytic rules. So analytic rules basically tell Sentinel what pattern should I look for in all this data that I've ingested, and when should I raise an alert. For example, every 5 minutes, check if the same IP is hitting multiple firewall deny rules. If yes, then raise an alert. So you can either use the out-of-the-box analytic rules as is, or as a starting point to then create an incident or a playbook. So then we have hunting queries. So hunting queries are how you go looking for threats before an alert fires. So they are proactive, not reactive. So for example, if analytic rules are alert me when X happens, hunting queries are show me if anything suspicious might already be happening. So hunting lets you look for weak signals, spot slow, stealthy attacks, validate if is this environment behaving normally. So now going to notebooks. So Juniper notebooks, while many common tasks can be carried out in the portal, it's called Jupyter Notebooks. Jupyter extends the scope of what you can do with this data to kind of do out-of-box and advanced analytics, data visualizations, and integrations. It takes it a step further. Then in the investigate box, we have incidents. So an incident is a single security case that Sentinel creates to represent a potential attack or security issue. They're basically like case files that contain all evidence, context, and actions for a security investigation. Then in the respond part, we have automation rules and playbooks. Sentinel can automatically respond to incidents using logic apps or playbooks. So examples include blocking IPs in Azure Firewall, updating IP groups, disabling accounts, or sending notifications. So this is where Sentinel acts as both a CM and SOAR, moving from detection to response without manual effort. So the key takeaway here is that Sentinel is a full SOC platform that covers collection, detection, investigation, and response. And when paired with Azure Firewall, Sentinel turns firewall logs into actionable detections and automated remediation, not just alerts. Let's look into that further. So far we've talked about Azure Firewall and Microsoft Sentinel individually. Now this is where the two really come together. So this slide shows how Sentinel turns Azure Firewall logs into real security detections, not just raw events. So Azure Firewall generates rich security signals, so things like denies, IDPS hits, abnormal traffic patterns, and threat intelligence matches. So Microsoft Sentinel takes those signals and applies analytics over time to turn them into meaningful detections, not just raw firewall logs. Now let's look at the existing resources or queries we have in the Sentinel's Content Hub for Azure Firewall and see what they do on a high level. So as you can see here, if you go to Sentinel and go to Content Hub and look for Azure Firewall, you can find all of these different uh, threat detections, hunting queries, etc. So these are all KQL queries that can be used to create analytic rules on Sentinel. So these analytic rules will then generate incidents or alerts based on matches of these threat detections. So for example, let's look at an example here. So the first one here we have is the port scan. So this rule detects port scanning behavior by identifying source IPs that rapidly hit a large number of different ports in short time window and raises a single high confidence incident instead of dozens of alerts. So we can then choose to respond to these incidents either manually, or we can choose to set up an automation rule that can run a playbook to update firewall rules automatically. Right, so we also have some playbooks that enable automated response, such as updating firewall rules or IP groups, etc., as a response to an incident. So playbooks are logic apps-based automated workflows. So there are some existing playbooks here. First one's add new firewall rule. You also have update an IP group, update threat intelligence allow list, and Shabaz will go over a demo of how you can use these later. So then lastly, we have the Azure Firewall Workbook that delivers centralized visibility into traffic patterns, rule heads, and security posture. So together, they help customers move from a reactive log review to proactive threat detection and response. With that, I will hand the floor to Shabaz, who will demo some of these capabilities for you. Thank you so much.
Yep, thank you, Sai. So hello, everyone. This is Shabaz. I'm a product manager in the Azure Network Security Customer Experience Engineering team here at Microsoft. So I'll be continuing with the demo of this Azure Firewall with Sentinel integration. So let's get started on that. So this is the scenario that we will be covering. So this is automated detection and response with Azure Firewall and Microsoft Sentinel. So here, if we look at this first layer, this is where we're looking at the incoming traffic. So all of the internet inbound traffic that is going through Azure Firewall that has intelligent detection capabilities with like threat intelligence, IDPS, and everything, so that all of the malicious traffic will be either blocked or alerted based on what setting we have configured on the firewall. The legitimate traffic, however, will go through to the internal servers if we have respective rules for that traffic that is configured on the firewall policy. So all of the malicious traffic that was logged by the firewall, it will be sent to a log analytic workspace. And we can configure that on the firewall itself, like where we can configure the diagnostic logging setup for firewall, and we can specify a dedicated log analytic workspace that we want to send the logs to. So from the log analytic workspace, the logs will be ingested by Sentinel. And then Sentinel, we can, with the help of Sentinel, we can do some detection and response to all of these logs. So first of all, Sentinel will run the analytic rule that is there, and it will detect malicious attempts from logs, and then it will create an incident, as we can see here, right? So once the incident is created, what happens is we have set up a automation rule. So that automation rule will be triggered automatically by the incident. So in that automated automation rule, we can set up some actions. So one of the actions is to run a playbook, right? So playbook is a logic app based automated execution that like Sai mentioned. So here, what we are doing with the playbook is that so it will extract all the malicious source IP addresses, and then it builds an IP array. And then what happens after that is we've configured this playbook to update an IP group that is being used on the firewall policy. So in this playbook, we are checking that existing IP group, and we are checking whether these source IPs that were newly retrieved by this incident are already present in the IP group. If they're already present, we're not taking any action because we are very well protected there. But if those new IPs that are detected by this incident, we like if they're not there on the in the IP group, then we will update the IP group with these new malicious IPs. So what happens is that those IPs will be added to the IP group, and that IP group is present in the network rules of the Azure Firewall. So therefore, any further traffic from those source IPs will be denied on the firewall right before they even go to they even go to the IDPS signature matches or anything at the network rule level itself. Therefore, the incident is contained. So this is the overview of the scenario that we'll be demonstrating today. So let me go through the setup. So this is our firewall. This is the overview of the firewall that we have, and we have an existing policy that is attached to it. This is a premium firewall. And just wanted to showcase that in the diagnostic settings, we need to configure the diagnostic settings to send all of the logs to a selected log analytic workspace. This is already present here. If we click on edit setting, we'll be able to see what logs we are sending, right? So here we are sending all of the logs to this log analytic workspace, and these are resource specific logs that we are sending here, right? And if I go back to the overview page here, so this is the firewall policy that is attached to this firewall, and let's take a look at that firewall policy. So in this firewall policy, if I look at the rule collections, there are a bunch of rule collections that we have set up here in terms of NAT rules, inbound, outbound rules, and internal rules, and all of those are present here. Let's take a look at the network rules specifically. So in the network rules, we have a high priority rule that says block malicious traffic, where we are having the source IP source as the malicious IP's IP group. This is an IP group that we are using. And from this IP group, anything to any destination on any port and any protocol, the action will be denied. So this is what we've configured, and the other traffic is set to be allowed, right? So let's take a look at what exactly is present in this malicious IPs group. So right now, we do not have any IP addresses. Just for demonstration purposes, I want to show how this automation will actually happen. Okay. So if we look at the logs, so if I just run the logs for NAT rules, we can see that a lot of inbound traffic is coming in, and this is the firewall's public IP. And after the NAT, it's being translated to some of the servers we have here internally, right? So out of those, there will be a lot of malicious traffic logs as well, because there'll be matches on IDPS, threat intel, and everything. So these are just some of the examples. But as you can see in the IDPS as well, there are a bunch of source IP addresses that are present here, which are actually attempting to do some malicious, with some malicious intent. They're sending out the traffic here, right? So since there are multiple of these and we don't know like what IPs are doing what, so it's really important to have some sort of automation in place that will ease our response to these type of distributed attacks in terms of multiple IP addresses doing all sorts of malicious activities. So let's move on to the next tab I have. So this is the Sentinel blade. So if we go to Microsoft Sentinel and we select the dedicated log analytic workspace instance, we'll be able to see the overview here. We'll see all sorts of details on incidents, automation, analytics, and everything. But the first thing I want to showcase here is the Content Hub section. So if we come to the Content Hub section and search for Azure Firewall, so here, as we can see, there is a solution for Azure Firewall, and with that solution, there are a lot of like artifacts that are coming in with that solution, like playbooks, detections, hunting queries, workbook, and everything. So if we just click on that particular solution, we'll be able to see the details here. We have 11 analytic rules, one data connector, 5 hunting queries, 3 playbooks, and 2 workbooks. Okay? So these are the details. So we have already installed the solution in our log analytic workspace here. But if it's not installed, let's say if we select some other solution that is here, for example, the WAF solution, it's not installed. So we'll get an option to install here, right? So since we have the firewall solution already installed, we don't need to do anything there. All of these, like let's say analytic rules, hunting queries, and everything will be populated as templates within the respective categories. So let's take a look at analytic rules section. So in the analytic rules section, if we go to rule templates, we'll be able to see there are a lot of rule templates which are downloaded from the firewall solution. So we have all of these options. We can just make use of any of these and we can create a rule. So for example, this several deny actions registered. This is the query that's there. There's a rule frequency, rule period, rule threshold, and grouping of incidents and everything. So we can configure all of those and create an analytic rule. And whatever rule that we create with this template will come to this active rules section. So for demonstration, for this demonstration purpose, we don't have any other active analytic rules here, except only one that we'll be using as of now. So this is more of related to malicious activity detected on the Azure Firewall. So as we can see, we have a dedicated query for this that will be running, and this is created through the templates that we have in the rule template section. And I've set up the rule run query as 7 days, rule period as 7 days. That means this analytic rule will run every 7 days and look for the data from last 7 days. And there are some threshold options that you can configure and also grouping of incidents that's there, so that if there are multiple incidents on the similar lines, you can group all of those incidents into one. So you won't have a lot of many incidents for the same thing, right? So that way you can activate this analytic rule here, right? So now, apart from this analytic rule, what happens is when the analytic rule looks at the logs and detects this malicious traffic, it will create an incident, right? So where do we see those incidents is that in the incident section here. And if I come to the incident section, there's nothing as of now. There are no incidents. So let's say if there is an incident, what happens is we have to set up an automation for that, like I mentioned. So let's take a look at the automation section here. What do we have? So we've already created an automation rule here. So this automation rule is basically saying we've given a name to it. So basically we are updating an IP group that is being used on the Azure Firewall policy. When this happens is when an incident is created. You can choose the incident provider, Sentinel, Defender XDR, since these are being combined together right now. But you can just keep it as all an analytic rule name. You can choose a specific rule name that you have that you want this automation for. In our scenario, we only have one active analytic rule for this demonstration, and we can just leave it at all for now. And the action that we are taking here is we'll be running this playbook, the run playbook action, and this particular playbook is being run once this automation rule gets triggered. So it'll run, we can define some of the order for this automation rule, like if there are multiple automation rules, we can give like 1, 2, 3 and sequential order in which we prefer to run these automation rules, right? And right now, as we can see, this is enabled, and I'm not going to make any change here. Let's take a look at this particular um, playbook and what it has, right? So I'm just going to cancel this. So if I go to the overview of this playbook and look at the Logic App Designer. So this is where we have the top level view of what exactly the steps will be taken care of in this playbook. So basically we'll get the incident, and then from that incident, we'll have the IP address details. And then with that, we'll create an IP address array, like I mentioned. We'll also get details of the IP group that we want to update. And then we will set those, we'll check whether the new IP addresses that we've got, they're already there in the IP group. If they're already there, we won't take any action. If not, we'll be updating the IP group with the new IP addresses so that the firewall rule will be automatically enforced. So that's the flow here. And let me go back to the Sentinel blade here. And now for us to see how exactly this runs. So right now, as we can see, there are no incidents. What I'm going to do is I'm going to go to the analytics section and select this analytic rule. For demonstration purposes, I would like to quickly disable and re-enable it. So disable, so that it will get triggered automatically. Otherwise, what happens is whatever schedule that you have configured for that analytic rule, it will get run in with that schedule, according to that schedule, right? So I'm enabling that right now, again right now. So this has been enabled, right? So technically we can think that this has run in near real time now. And what that does is it will detect all the malicious traffic, and it should be creating an incident like we mentioned. So let's look at the incidents. There are no incidents right now. Hopefully there should be one created shortly. Let's give it a couple of minutes. Generally, it should come up by this time. Uh, it's taking some time. Okay, there you go. We have the incident now. I skipped a beat for a second because it wasn't coming up, but anyways, we have the incident. So what we expect from this incident here is that it should give us all of the malicious source IP addresses. And if we look at we'll view full details here for this incident. We'll be able to see all of those malicious IP addresses that matched the analytic rule. Now, what we are expecting is that the automation rule is triggered already, and it should have run the playbook, and the playbook should have updated the IP group. So that's the expectation. So let's see. Let's go back to the logic app that we have, and let's see the run history. So it just ran 1 minute before. So that's the local time here in India. And so it ran successfully. So that means the change happened. And the IP group should have been updated already. So let me go back to this IP group. Now, previously we didn't have anything here. Now let me refresh this. Boom. So we have all of the malicious IP addresses here in the IP group. So what that does to our firewall policy is that all of these IP addresses will be automatically blocked by this particular rule, since we are using that malicious IPs group there, IP group there. Right, so that's how the automation works, and we can set as many analytic rules. We can modify the logic as we want, and it can vary depending on the environment's requirements, right? And you might be having a question of where we got this playbook and how to install that, right? So this playbook is available in the solution, the firewall solution. We go back to the Sentinel page and look at the Content Hub firewall solution. You should be able to get the playbook there. But we have already also recently created a simplified version that we are using here for the add to IP group. So if you go to our Azure Network Security GitHub repository, under Azure Firewall, we've recently added the playbook add to IP group with REST API. So this particular playbook is not using any uh, custom connectors. It's directly updating the IP group with the help of API. So I highly recommend everyone, if they would like to try with this scenario. This is pretty simple and straightforward to set up. Get this playbook from our GitHub repository and install it and try out the scenario. If not, if you want to use a custom connector from Sentinel, and use the ones in these, use the playbook that is present in the Sentinel solution, you can do that as well, right? So that's the overview of the demo. A couple of things I wanted to highlight. So if we go back to the Sentinel Blade, um, there are also other tabs here. Um, there should be a tab for workbooks. So there are workbooks for Azure Firewall. These are part of the solution. One is for the legacy logs and one is for the resource specific logs, which are the structured firewall logs. So you can just view and install that template, and then you'll have the workbook ready. So that'll give you the centralized dashboard with all the logs that is like all the traffic that is traversing your firewall. So that's a bit about the Sentinel Blade. One quick important thing I wanted to highlight is that this is the Sentinel Blade is currently on the Azure portal, right? So this will be retiring soon. We will have the same functionality and everything in the Defender portal. And after March 2027, this particular blade in Azure portal for Sentinel will not be available. So it's better to take a look at how the new Sentinel blade is in the Defender portal and start transitioning to it. And therefore, I just wanted to showcase how it looks on the new portal. So this is the new Defender portal. You just go to security.microsoft.com and you'll be able to go to the Defender portal. And under Defender portal, this is the home tab where you see all of the information about what are the security risks and everything for your environment. So you'll have XDR, you'll have Defender, all the Defender features, and you'll have the Sentinel also in this particular portal. So if you just go to this, expand this Sentinel section here, all of the features that we saw in the Azure portal, we should see everything there. For example, under the configurations, if I go to analytics tab, all of the same features are here. If we go to the rule templates, we should be able to see the rule templates and everything. This is under a different log analytic workspace. We have to connect the respective log analytic workspace to the Defender portal in order for this to work. So there's a definitive process for that. Feel free to check it out. It's in the documentation, and it's pretty straightforward. As long as you have owner level permissions or contributor level permissions to the log analytic workspace, you should be able to add it seamlessly to the Defender portal. And all the other tabs are equally functional in this new Defender portal as well. You'll get the templates, you'll get the hunting queries, you'll get the automation section and everything. So feel free to take a look at it, and definitely it's like everything at one place, and it's even better and greater. Right? So with that, I'll be stopping here with the demo. And I'll move forward and give some time to Q&A. Any questions do we have here?
Yes, thank you, Shabaz. And just so you know, Sai did have to drop, so she's no longer here, but we do have a few questions. So the first one says, as there are multiple rules and queries for a data source, how do you determine which one to use? Is there cost involved with running the rules and queries in Sentinel?
So there is cost involved as per the ingestion and for Sentinel. So you can check that up in the documentation. In terms of multiple sources, here we are talking about integration of Sentinel with firewall. And specifically, even for firewall, we want to be very specific on what exact type of detections we want to have. If we want to have detections related to certain patterns, detection related to IDPS, detection related to threat intel, we have to be very specific and create an analytic rule according to that. And then it differs with different products. So it's like case by case basis where you have to take the best call and evaluate your requirements and then set up the analytic rule as needed.
Perfect. Okay, and then our next question says, With regards to integration of Sentinel into the XDR portal, currently XDR raw logs, like device logs, are available for free for 6 months in XDR. With the integration of Sentinel and XDR, how is access to those XDR raw logs, would that work? Are they available for 6 months in the log analytic workspace, since Sentinel retention is only for 3 months for free?
So this particular webinar is focused on network security and network security, especially firewall integration with Sentinel. We do not have much information on the pricing of the latest integration, what all periods that we will be getting for first 6 months or anything. All of those details we'll have to check with our teams, but we encourage you to submit a feedback, and we'll be getting back to you with the questions you have. And we'll have the right answers for you.
Great. Our next question says, can Microsoft internal IP addresses be included in dynamic malicious lists?
Yes, of course. So both internal, external, any IP addresses, as long as they're part of the logs that the firewall is logging, and they could be used for updating the IP group or creating a new rule or adding to a threat intelligence allow list, whatever we want to do, we can do for both internal and external IPs. In this scenario, I showcase the external IPs, but it's equally it equally applies to internal IPs as well.
Thank you. Our next question says, is Azure Firewall different from NSGs?
Yes, definitely. So NSGs are more of like your inbuilt filtration for traffic that is coming with your NIC, or it's possibly with your subnet. But Azure Firewall is altogether a different a product in itself, which gives you advanced capabilities like IDPS, threat intelligence, TLS inspection, which you usually don't find in a simple network security group. However, both of these are important in terms of defense in depth approach. So you have to have the security groups enabled, but that's not your only stopping point. You need to have a firewall for any enterprise, for any small SMB businesses. The firewall is really important, and it's important to enable the inspection related features on the firewall to get the best out of it.
Great, thanks so much. And it looks like that was our last question. So thank you so much to both Shabaz and Sai for being our guests today. And Shabaz, is there anything else you wanted to add before we close out?
No, I think that's about it. Thank you everyone for joining, and I hope this has been informative for everyone.
Wonderful. Well, thank you so much, everybody, for joining today. And to all the listeners that are still on the line, if you're someone who wishes to aid in the protection of the world from cyber threats and desire to have a say in shaping our strategies, blueprints, and recommendations, then we invite you to become part of our security community. Join us at aka.ms/security community. This is also where you'll be notified about all of our upcoming webinars, events, and other announcements. Thank you all for being part of our community and for joining us today. We hope to see you next time. Goodbye.